Good afternoon and welcome again to this program on Hadoop benchmarks and the installation which we saw today. So so in before so in case there are some queries, you can either you can either share it via the chat box or you can directly ask interrupt me at any time during the course of lecture. So we had discussed this Hadoop and MapReduce. So as a whole, so if you summarize what all happened is that there's what sort of workflow is there in this Hadoop. First, what we will do, okay, I think my screen has not been shared yet. Just a minute. Let me share my screen. Sorry, your entire screen. Okay. So what has happened today? We discussed Hadoop. We discussed its components, primarily the MapReduce and its distributed file system. We saw the motivation behind Hadoop and everything. We saw the installation. So if you summarize what all is happening in Hadoop is that what we do, we load data into the cluster. Data is loaded into the cluster using we used a command hdfs dfs hyphen put. That command, we analyze the data. Analyzing the data means we use MapReduce as the prominent paradigm. It works by map and reduce, which we all used. We use the command Hadoop jar, like that, the location of that jar file and input and output and the name of the benchmark. We stored the results in the cluster using HDFS write, and we read the results from the cluster, like the part hyphen r, and that five zeros, that is the output file. In case there is output, sometimes no output comes, so you cannot get that part r hyphen r dot uh, uh, hyphen five zeros. So this is the typical workflow of a Hadoop MapReduce program. So in the last session, we had discussed about this MapReduce, this word count, the easiest benchmark, that is the simplest and easiest, that is word count benchmark. So let me just let me just summarize what we did. For those who have not yet joined, or for those who have joined late. See, okay. See how to run a word count benchmark. How to run word count benchmark in Hadoop. But see, ensure all the daemons are running in the Hadoop. When you start SDFS and you start DFS and yarn, you see whether all the daemons are working properly or not. That can be done by JPS command. JPS will give all the set of Java processes which are running in the cluster. Prominently among these are this secondary name node, node manager. All of them are prominent. Secondary name node, node manager, and name node, they are used for the DFS. And this resource manager and node manager, they are used by the yarn. But we have already created a file called wc.text as in the above command. Now let us see what sort of create or download any text file. You can either create any text file, you can download it from the internet. LS says there is a file called wc.text. This text file will be the input to the MapReduce program. We will create. Okay, this is the file which we have created. WC text, it contains some plain simple statements. Now let us run our program Now let us run our program on such a file. We will create another file like this. We will create another one file. We will paste it. We will save it. Let's run the program. Let's run the word count program here. For running the this thing, we have to the first thing is, since I has already pointed out, what files you are creating it in the local file system. When you are creating the files in the local system, then you can put the file into the DFS, into the distributed file system. How to copy the file is sdfs dfs hyphen put. That is the command, and the real location of the file, and hyphen put. The real location of the file is Hadoop, is slash home master. Here the user is master. Previously it was HADACC. Now it's master. So you have to take these things into care. Okay, it will put the file into the distributed file system. You can view the file with ls command. This is already put. It will take some time. Okay, no, no, no. You have to put that file. You have to give the file name. I forgot to give the file name. Now you have to put the file name here. It's a directory. Right now you have to put that file. Okay, this is the command. This will put the file into the DFS. You can view the content inside the DFS using ls command. Check whether the file is present in DF. Copy. Okay, that is done. Now check whether the file is present in DFS or not. How to view it? You can use ls command, sdfs dfs hyphen ls. Okay, see, wc hyphen 1.txt is already present. Now you can even view the contents of this file using the cat command. But you have to use this sdfs dfs for that. Run the word count benchmark and check the job counters. To run the word count benchmark, you have to go to the actual jar file. The actual jar file is in the opt folder. Hadoop jar, you have to invoke such a file, and the location, just the location of the that jar file. It's very difficult to actually remember that name. I have just copying and pasting here. It's difficult. It's a long name, slash opt, like that, various things. See, you can, this is a very big name. It's very difficult to remember. So you just copy it. You just copy it from somewhere and paste it here. Now, since we are running word count, we will use the word count program there. These all programs are in the jar files, in that map reduce hyphen examples. This one, this is placed here. All of the files are placed here. All of the benchmarks are placed here by default. Word count, you have to use an input and an output. Input will be the wc hyphen one text file, and output will automatically be created if the file runs with success. That's a condition. That's a condition. This is uh, the URL to track the job. This, if you click it, you can view the job status. See, map and reduce. See, map completed. Now reduce will get completed. Map reduce. See, these are the set of counters which we get. Check the output via HDFS and terminal. Check counters. We can check the counters. Various sorts of counters will come up. Job counters. Various this thing. Now you can check if you view the file, there will be only seven records. Records mean line by line, line by line. Now we can view the output via both the terminal, via the this thing also, via HDFS also. Whenever there is output, remember that part R, part hyphen R, and that hyphen 505 will be created. If that is created, that means your output has been successfully this thing. Output has been successful. WC1 test, click on that. Head the file. This will show the top contents. See, here's the program, this one. See, there are only seven records here. One, two, three, four, five, six. There will be seven. There will be seven. There are seven. There are seven this records, and there will be a part 00 file. This is the contents of the file. And let us view the output via this terminal SDFS DFS. This is the cat command. Ls you can view the this part R-00. This is this is the output is generated. See, within R, this is the success. If this file is created, that means this has program has been successful. This is nothing. This means the success. This will be the output. Grep is once, Hadoop is thrice, Hadoop dot is thrice, everything. This is the word count program for you. Now let us view it by terminal. Let us see that part hyphen R, these five zeros. File via terminal. SDFS or DFS. You have to remember these commands. Hyphen R. This this should be hyphen R. Part hyphen R. This is the file. We are viewing this file from from this from DFS. See, this file is already there. We will use a cat command to get the contents of the file. This is the output of your file. That means this is the occurrence of various words in the file. This is your output. Okay, this culminates this word count benchmark. Let us look for other benchmark. If there is any question, you can let me know. Okay, just a minute. I do not know why this is not working fine. Okay. It seems to be what quick to Windows. Slide should start from the current slide. As I pointed out, what's the need of benchmarks? Benchmarks are whenever you set up a cluster, you do not know whether the cluster works fine or not. For letting the performance, for letting the bottlenecks know about, for letting people to know bottlenecks of the cluster, we run various benchmarks. These benchmarks are used to know the performance of the IO, the performance of the network, and the running time of various benchmarks. So what we will do now, we will use another benchmark, which is use pi benchmark. Pi benchmark means it calculates the value of pi. Because pi has the value of 22 by 7, it has a means the to get the actual value, it's quite difficult. So we will use such a benchmark. We'll run pi benchmark. Now what are the various things about that is, as I pointed out, that in a map reduce program, map tasks are always run parallel. After map task finish, then reduce task gathers that very little information from the map task, because the output from map tasks are quite less. If the map outputs are quite less, that means reducer will just work. Reducer had to very means it has to work very little. Other One more point to be noted is map tasks start at the same time and the job finished when the last map task completes. It's because the reducer time is quite less there. Pi benchmark had low network traffic. That means there is hardly any traffic. That's why it requires a trivial amount for a reduced task. We can see how the benchmark runs. So starting, it's the same procedure is there. You just check, you just use JPS. JPS notifies what sort of daemons are running inside the system. After that, you will make various directories, because it will require input directory, and then it will let us see some commands. Let us see some commands before moving to pi benchmark. Let us see some commands. How to make some directory, how to remove directory in a SDFS. It's the same thing, but you have to use something different here. SDFS DFS hyphen make dir mkd. It will list all of the contents inside this SDFS. Nothing is there. It should be hyphen ls slash. Make dir 3. We create a directory by the name of TP. Let us create this directory. This will make a directory inside the DFS. You can view it using the ls command. We can either view it in the command, we can view it in the term, this thing also, within the name node. You have to reload it and go to the utilities. See, this TP directory is created. We can remove that directory rmdir. This will remove the directory from this. Now, if you rerun this, you can get that there is nothing inside this node in the browser directory. Now what we will do, we will go to the root. For going to the root, sudo su is required. It will ask for authentication. You have to give your authentication. After that, what we will check, as I earlier pointed out, so to know where the actual MapReduce examples are there in the Java file, it's very difficult to remember that location. So for finding that, we will find a way how to easily retrieve that. We will use a command. We will use a find command. Find slash is the command with name within inverted commas and within that star star star. We will use Hadoop example Hadoop examples and jar. Kare khol chi. See, when it runs, it will give the various locations of the files. That means it matches those files which have contained this Hadoop examples and .jar. It will take some time to run. See, the output has already come. Various things, various locations it has given. Now we will look for the map reduce example jar. That is the actual locations. OPT. It will be under the OPT folder. That means this one is this. First one is the actual location. This one is the actual location. Because Hadoop was already placed in slash opt. Now, if the above you can yourself see, since we download the Hadoop in the HADACC, it also contains various things. But we have extracted there and we had moved to this location slash opt. Now we will move to the HADACC account. We just copy this location and we move out of the this route. We have copied this, we will move out. Sudo su sudo it will go to the Hadoop account. Now we will run this. We got the location. We will run pi benchmark Hadoop jar and the location of this. See, if you look at this, what I had used is Hadoop jar and I had just pasted that this copied line. But it shows various sets of benchmarks which are currently available in this map reduce dot example. One is aggregate word count, aggregate word hist, some db count, grep, join, pi, random text writer, random writer, various secondary sort, terra gen, terra sort, terra validate, word count, word mean. Go various. That means various benchmarks are already in this folder. Map reduce hyphen example. You just have to know the location of this folder for invoking it. Now to run the pi benchmark, what we will use the same location with the name of the benchmark and with some inputs. All sorts of information. If you want to get further information regarding these benchmarks, you can find it in the Apache Hadoop. Now for invoking that, what we will use this Hadoop jar location of the file pi with this input and output. You can study various things. It gives little bit information about the benchmark. Pi benchmark. It estimates pi using quasi Monte Carlo method. How to invoke is this? It's the same thing. Hadoop jar, location, and this thing. This is use pi, and you have to give the specific number of map tasks you want to give. It wholly depends on you. My machine is not very heavy, so I have used a few operations. 5 is the number of map tasks, 10 is the samples per bytes per sample. So you run it, you will get some output. If your cluster is means if your machine is not heavy, sometimes this fails the job. So this is the way to run this pi benchmark. See, number of it's yes, it's see what happens. 5 samples, 5 maps, and 10 bytes per sample. It takes some time to get samples per map. It's 10. See, there is an error. Means it has not success. It has not been successful. Actually, what happened was that my machine, its actually memory is quite it's less. That's what the error came. Let me show it how it successfully run. Let me show it. Let me show it how it ran successfully. This is the way. Ensure all daemons are running in the Hadoop. So for that we use JPS. It's the same set of operations which we perform. Okay. Ensure that all of the daemons are working properly. Now just create an input and create an input. Just you can check the DFS how much it is the usage currently. Every information you can get. See, DFS is only used for 1.3 MB. Rest non-DFS is 12.17 GB. You can put various files and ultimately it will get stored there and the quantity will get increased. See, I have just lowered the number of maps and samples per input in the map. I've lowered it. See, this is the way. 3, 3 and 3. These are the arguments passed. Number of maps, samples per map. C. Wrote input for map 1. That means only 3 maps are invoked. Now, just see. This is the URL to track the job. When the map finish, automatically the reduce will finish because it only takes a trivial amount of time. And check the resource manager also. See, map is 0. See, map is 0, reduces 0. Map is 100%, reduces 0%. That eventually the reducer will take quite a lesser time. See, you can see this name. See the It's via cause Monte Carlo. Various times when it was, what was the starting time, what was the launching time, what was the finishing time, and what is the current status. That means it has succeeded. This, whenever you run any MapReduce process, containers are launched in an application. It will give every information regarding this. Since it has completed, it shows any not acknowledged. Check other reducer has to see the what are utilized. See automatically, if you can see, this map got completed at 55.51, and reducer just took 30 odd seconds to get completed, because it reducer has very little to do in this pi computation. You can check the job counters here. बैटरी पका मैं बैटरी पका बैटरी ने पका नहीं क्या को. You can check various job counters there.
How are just the side of origin?
बैटरी में बुरी
Hmm?
बैटरी में रहना खराब. खराब है.
Ikaw? Ito kailangan.
पावर अच्छा.
Power ito.
अब नहीं अच्छी कोई. बैटरी at the output you can see what is the, at the end you can see what is the estimated output of this thing. Pi, this marks this another benchmark. Full battery. अच्छा 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 ना ठीक है चला. Okay. Yes. Are there any queries for it?
So I comment? Hmm?
Yes. Are there any queries for word count or pi benchmark? I can proceed further. Okay, let me proceed further bit more. What other benchmarks are there? This is one of the main benchmark, TerraSort benchmark. Let me tell you what actually is the TerraSort. Terasort. See, Terasort is used actually. Terasort benchmark measures various. It's a both map intensive as well as a reduced intensive task. Means both map has to undergo computation and reduce has also to undergo computation. It's one of the best benchmarks for this for measuring the performance of your cluster. So it is itself divided into three steps. First means teragen. In this teragen, we generate the load. That means for sorting of data, you require data. That means teragen is used for generation. It generates load. Terasort sorts the data. That means Terasort has the algorithm. It will sort the data. And Teravalidate is used for validation. Okay, whether the sorting is fine or not. Terasort implies sorting any amount of data as fast as possible. It tests both HDFS and MR layers of an Hadoop cluster. How? Because during generation of data, it measures your IO, and during map reduce, it checks whether okay map tasks are running fine, reduce are running fine, network is also fine, because it also generates a lot of intermediate data. It is helpful to determine whether map or reduce tasks are perfectly working fine or not. As I earlier pointed out, it's both map as well as reduced task intensive. Teragen is generated to the load, and besides, each key generated in the teragen is of 100 bytes, is of 100 bytes. And what does this Teravalidate ensures that the top of terasort is globally sorted. That means all generated load is globally sorted or not. Teravalidate creates one map per task in the terasort. This is the actual workflow. For generating the load, you will use this some user HD user terasort hyphen input. For this terasort output, you have to use this sort of location user slash HD user terasort hyphen output. And for teravalidate, we do not use teravalidate. Okay, these are the set of commands. These are the set of steps you require. Suppose, see, in the first command, what we use Hadoop jar file, actual jar file location, teragen, and thousand SDF. What does this mean? If we have 1,000 records, as I earlier pointed out, each record is of 100 bytes. That means the total workload is 100,001, means 10 power 5 number of bytes. That means 10 power 5 bytes are there in the this. It's the workload is total 10 power 5. For running the terasort, you will give that Hadoop jar location and the actual file location with terasort and the output directory. Same thing as with this word count and this pi. Teravalidate will validate, and this didn't, so you have to see one more thing. If you suppose you have once run an terasort or teragen. Now if you again want to if you again want to run on a different load, so you have to, what workload you have created, you have to delete the workload from the SDFS output directory. That means that is required, otherwise you won't be able to run this terasort within the terasort directory. Now let me show how to do it. For generating terasort benchmark, see, before sorting, you have to generate the load. For generating the load, this is the option. Generating the input via interaction. How to generate is use that Hadoop jar file location and Terragen and specify the number of specify your load. See, this command we will use. Hadoop jar examples like number of bytes is 100 and the output directory. That means each key is 10 bytes. Each key, the size of the key is 10 bytes and 10 bytes row ID with some filler inside it. You have to be sure what is the input directory and what is the output directory. Otherwise, there might be a problem. The input of the Terrasort will be the output directory of this Terragen. Remember that. You will sort the data which Terragen has created for that. That means that input to Terrasort is the output of the Terragen. Let me show how to generate the load in the Terragen. In the Terragen, you can check all of your whether all the cluster is performing well or not, because it's as pointed out earlier, it's a both map as well as reduce intensive task.
I guess good thing. How does it?
Let me read both the input and output. I have already run it. Let me delete it both. See, this is the input and output generated. So you have to delete both of these. -rm, I think the commands are same. Same thing. We will delete the output. Run Terragen suppose with some keyword with some parameters based on your cluster. If you feel that, you can even run a 10 GB job there. See, what it does is it is Terragen. Each sample is 100. I am using 10 samples. That means 10 samples I have created, each of 100 bytes. This is the input. Input location is this. No, it should not be Terrasort input. I think so. Hadoop jar. It must not be Terrasort input. Just a minute. Let me. If it okay, you have to mark it. Okay. This is the name of the directory. OPT Hadoop. This is the job which has been created. Job has started. Terminal displays a link. Job has started. Right? You do not know what is the status of this job. You have to again run it in the this browser. Now see, this has been generated and now various things have happened. You can check the status. Terragen map task 2. Now why map tasks are 2? Because this total size is 1000 bytes only. 1000 bytes only. So based on that, you can see there are 10 records each of 100 bytes. All both of these map tasks are local tasks only. That means this output is generated. Now we can check how to run this output. How to run it. Now previously we used TerraGen. Previously we used TerraGen. Now we are using now TerraSort. We are giving it input and output location also. It will run with some. See, I have already written that my system is little slow. It gets into deadlock state. You can check the resource manager for the job counters yourself, because the configuration of system was not very good and the memory was quite less, so it was not possible for when I used when I run this benchmark in my laptop. It was means the memory was quite low, so it was showing errors. Let's see whether this runs or not. Otherwise, if you have a good configuration, you can run it. Two inputs. Job has started. Let's see whether it will progress or not. Job has completed. See, job has started. Map has completed at 22:36. Reduce has completed at 22:23. See, job has been completed successfully. Otherwise, you can create a big load and you can run it in your this. You can check, okay, all that is working fine or not, and check various other counters and check the resource manager for what resources are allocated here. This completes our this thing. Terrasort benchmark. Terrasort basically sorts your data, so that marks the end. So are there any questions? Are there any questions? If there are any questions, I am open for any questions. I'm open for any questions. If you are not able to, means you can. Okay, I am. I will share. You don't have to worry. I will share this materials. I will share all materials with you. You don't have to worry it. So if there are any questions, please let me know. Either you can put it in the type box, or you can just you can on your microphone and you can ask me. Now, after this TerraSort, what we have also one more benchmark. Just a minute. Start from the current slide. TerraSort is done. WordSort. Yes, yes. One more benchmark is there. One more benchmark is this. This grep benchmark. Grep stands for General Regular Expression. Those of you people who have studied this theory on computation, they might be well equipped with this word. What grep does is grep matches a string. You have a suppose you have a file, you want to search some keyword inside it, you use this sort of benchmark, that we call it as grep benchmark. Grep benchmark is used to match a string with the text under consideration. grep stands for general regular expression. Now, for running such a benchmark, we create two directories for, like, as in every benchmark, one for input and one for output in the HDFS location. Various commands for making various directories inside the HDFS. Okay, one more thing is that, as I earlier pointed out, if suppose you want to find a keyword inside a string, suppose that keyword is not present inside the string, that means the success will not be generated. That means part hyphen r and 50, the output will not be generated. It will be only generated when the string matches with the current text. So HDFS DFS put will put the local file into the HDFS, and this for running this benchmark we use grep with the same input and output. Let us see how to run grep benchmark. See, how to run a benchmark is you have to create directories for this input and output. You have to create directories. So let's see how it works. First, you will check whether all the Java processes are running or not. I have made this video quite slow so that you are able to understand what is going there. So be patient and see what is happening. Although you know everything, as I have already demonstrated that what happens. Ensure that if you are running, ensure that all of the daemons are working. Otherwise, you will not. Otherwise, your job will fail. JPS shows everything is running. You will put some file into. You will create a file, or you will put some file into the DFS. One source file, one destination file is there. Now these commands. You can view these files whether these files are created both within the terminal as well as in the this SDFS. See what has happened. Let me just demonstrate what has happened. What I did is what I created two files, source and destination one. Now what I am doing is I have location of one of the file. What I am putting SDFS DFS. I am putting this file into the DFS. This core.site.xml into the this source one file because it might have various keywords inside it. Now you can see whether this has been. See, within source one, if you view that file, code.site.ml is that. You can see various content inside the file, see various things. So Apache Hadoop, various things. Now let me see how to run this thing. How to run this grep benchmarking. You will have input, you have an output. You will search for a string. Suppose this Sinha. I am using my supervisor's name. Whether let me see whether Sinha is present there or not. You have to mark the this correct location. What is the input? Source one. Okay. You will use the grep command. Let's see whether this Sinha is not present there. Let's see whether this shows or not. Job has started. This is the this HTTP link for the job current and this application. See application attempt. Map is running. Map has started. See, this is the various applications running, various status of various applications. You can just check. When you run such benchmarks, you can get to know, okay, this is the application this is running. Node local containers, various containers are launched automatically when you run various applications. Since this system is quite slow, you're not able, it takes too long. And at that time, the job gets completed. If you run in a good system, you can yourself note the performance. Total allocated containers are 3. This gives various information about this various applications which you launch. Now you can also look what sort of various cores are there. My system has only called, I think, 4 processors, but the cores are more as compared to the total number of processors. Now this has finished. Various things, various information you can get it. What is the total elapsed time? It's showing 52 seconds. You can check the history, when it was launched, when it was started, and when it got completed. You can check all sorts of information. The counters will be, you can check this counters, read write operations, what sort of, only one map task is there, only one reduced task is there, data local map task is one only. Now see, there is only one map that got shuffled. The number of shuffled maps is only one. Reduced shuffled byte is 6 only. See, since Sanaha is not present, I think there should be no output generated. Core site.xml. Source one course site.xml. This is the file. This is the file. No Sinha is there. No output will be generated. You have to go to the destination. See, nothing is generated. No output is generated. Now the thing is that since there is Sinha is not in the file, no output will be generated. No output means part hyphen r, that hyphen five zeros. That means no output is generated in this case. When the string does not match, same thing will happen. Destination will be empty. I think there seems to be a question or something else. Let me see. Is there any question? No. There's no question yet. So let's see. Let me see. The DFS capacity has also increased from this to this because we loaded something into the DFS. Live node, every information you will get about the cluster. So if you run in a, just suppose of two, more than one machine, you can get various things. Within one, because there's a limitation of memory and various things, you are using dual. Mostly I have dual boot system. So my half of the memory is gone to Windows, little is gone to the this Ubuntu. So for me, the resources are not very much. So if you have a, if you configure as we have configured in 6 to 12 systems, it was, you can very well run big jobs. There is other demonstration of this. I think that will be, is there any question? Let us ensure all the daemons, same thing. All the daemons are working in the node. All of the daemons are working. Now we will create directories both holding source and destination. Here I am using env.sh. I am putting it into the input. It's already it's already put in the this thing in the DFS. You can confirm it from this name. You can run it and you can check the input. It will hold this file. It will hold this file env.sh. You can check the contents also. So now when that is put, we will run this grep benchmark. That is already done with source and a single string that needs to be find out. I will use the same string to check whether this is present in or not. Job has been launched and it will take some time for the job to get completed. See, you can run it. You can see all of the applications which are running. See, topmost application it's running. It's the submission time and it's you can click on it. You can get more this information. Grep search. See, it has elapsed 23 seconds has elapsed and various logs you can get. If you click on the logs, you can get various information. So map is already complete. Reduce. If you attempt a big, if you create a big file, you can get lots of map tasks. Right now, I as already pointed out, my memory is quite less, so I have used only a few. Means the file used is quite. It's not heavy in size. These are the set of counters. You can see. You can see the counter since Sinha is not there. No output will be generated. This was the file. There's no Sinha, so no match happened. You can check the output directory. Output will not contain anything because it did not match with that string. So these are all the set of benchmarks which this marks the end of this session and running of benchmarks. If you have any queries, you can please let me know either by switching on your microphone or by chats. I am open for questions. I'm open for questions. If you people are willing, we can share our. We have made some contribution in Hadoop. I can share it. If you are willing, if you people are willing, so I can share you all the. I can let you know what we have did in what we did in Hadoop, how we optimize the performance of the Hadoop. Few people are willing. Moya, hello, Moya, hello.
Yes,
Yes, Moya. What to do? I think
if there is no more question, I think we can end the session.
yes, I can end this. If they are willing, I can share what research we have done in this Hadoop. We can share what contribution we have made. If they are
Okay.
willing, but
Is
hardly.
there anyone interested from the participants?
I do not know whether they all have muted their microphones, and so they just asked for sending the feedback link
The
and ask
feedback link will be sent at 4 p.m. after this session.
what.
So, is there any question?
Yes, is there any question? I am willing. Yes, I'll more. Prabhu has asked, raised a
Okay.
hand. Yes. You can please. You can on your microphone, or you can just type your question in this chat. Yes, please ask your questions. I know that there are various. There might be various queries, but you people have to ask.
Okay, then. If there is no question, I think officially we can end the session.
Let us wait for 2 minutes. Let's see that if anyone is willing to
Okay.
ask a question. Let's wait for 2 minutes. What about the next session? What we have to do in the next session, Moya?
Please go through the schedule. Did they send you the schedule?
Yes. I received that schedule. The schedule mentions that there's a discussion at from
Yes.
4 to 5.
Yeah. If there is no one who are interested in discussions, then we can end for today.
Okay.
So if there is no more questions, then okay. Here is one question.
Yes. Is what BDAS? I do not get it. What is this? Mr. Vishal Kumar, can you elaborate? Can you switch on your microphone and let me know what is this BD is existing on Big Data Analytics as a Service? No, see, our research is mostly focused on performance optimization. I Today I shared you various running various benchmarks. What our aim was to lower the completion time of the job. That was our main part. If you are willing, I can let you know how we have means decrease the completion time of the job. If you are willing, so I can present you. Besides Mr. Vishal, is there anyone who want to ask a question, who wants clarification from today's presentation, whether be it from the Diptindu sir or from me, from my side? Well, yesterday they had some session from 4 to 5. Boya, hello. Hello, Moya.
Yes.
Yesterday, had they any session for 4 and 5?
Yeah, there is a short discussion, but today I think no one is interested in the discussion.
What to do? I have no
Yeah,
idea.
we can end the session if there is no one interested.
Just,
So, from
just
the participants, if you are interested, please turn on your mic and you can say anything you like.
if you
By the way, feedback link has been sent to your mail. Please check your mail.
if you're willing, I am telling you, I have the PPT. I can make it quite easy for you people to understand what we have done. what contributions we have made in Hadoop MapReduce. If you people are willing, you let me know. I can take 10 or 15, not more than 15 minutes. I can just let you know what we have done. I think everyone is asking for feedback link, Moya. You will share it after 4.
Okay, it has been sent. It
Okay, it
has
has been sent.
so I
Okay.
think we can end the session for today.
Okay. Shall we end? See,
Okay, I think there is no more question, no more discussion. And
I,
here, among the participants, they are asking for PPT.
yes.
So
Okay.
the
I'll
PPT,
share. I will share the PPT. I will share the PPT.
all the resources will be shared to the participants at the end of the workshop.
Okay. Okay. At the end, I can share all that materials to you only. So you later on send it to the participant, to all of our participants.
Okay, I'm stopping the recording, and
Okay.
then we can stop. Okay, we will meet tomorrow at
Okay.
10
Okay.
a.m. in the morning.
Okay.
Okay.
Then, if there is still any query, I am available. I am available for you.